example 2a, we have an equation. I don't know why this isn't on your note sheet, sorry. We are going to find the vertices, foci, and asymptotes of the hyperbola 4y squared minus x squared equals 16, and then sketch our hyperbola. The first thing that we have to do, if you notice our equation is not in standard form for hyperbolas, we have to divide both sides by 16 to get us in that standard form. So that gives us 4y squared over 16. 4 over 16 is 1/4. So y squared over 4 minus x squared over 16 equals 1. Now we are in the general form, and we can keep going from here. Well, right now, since my y squared comes first, that tells me that my hyperbola is vertical. It's up and down. Let's start off sketching what we know and what we can. Okay. Since y squared comes first, again, our hyperbola is up and down. This 4 comes first, and with hyperbolas, this first number always tells us where the vertices are. So we have a vertex at 2 and at -2. And since our hyperbola is going up and down, that means those vertices are on the y-axis. So I guess that's the first thing we can answer. We can answer where our vertices are at 0 plus or minus 2. We also want to figure out where the foci and the asymptotes are. Okay, we use the 4. The 16, that doesn't tell us where the foci are, but that tells us the other dimension for that central rectangle. So that means our central rectangle goes out to 4. And that it goes out to -4. And these diagonals of our central rectangle is where we get the asymptotes for our hyperbola. And knowing that alone actually gives us a really good sketch of what our hyperbola is going to look like, because we know we have our vertices here, and we know we have the asymptotes. So our hyperbola has to follow those asymptotes along the way. Okay, well, while we're here, while we have our asymptotes drawn in, we might as well figure out how to write those asymptotes. These asymptotes are just lines. So let's think, how do we write the equation of a line? Y equals mx plus b. And since our hyperbola is centered at the origin, our y-intercept is 0. Our slope from this end to this end of our rectangle, we go 2 and over 4. So that's y equals 1/2 x. Y equals 1/2 x gives us this asymptote. Our opposite slope gives us our other asymptote. So y equals -1/2 x is this guy. So together, our asymptotes are at y equals 1/2 plus or minus 1/2 x. We know our vertices are at 0 plus or minus 2. The only thing we have left to figure out is where our foci are. And our foci are always inside our object, inside our parabola, inside our ellipse, inside our hyperbola. I just don't know where the focus is yet. So right now I'm just going to draw in a point. with my pencil here. And let's draw in what our right triangle is going to look like. So our furthest point is the point that we don't use when we make our right triangle. So in this case, with our hyperbola, we're going to use our vertex, the origin, and then this other dimension for our central rectangle. I'll go over that again. And then I'm going to pull this right triangle out to the side here. I know my vertex is at 2, so that tells me the height of my triangle. I know that my central rectangle goes out to 4, so that's this length here. The only thing I don't know is C, and that's going to tell us where our focus is. So work out your Pythagorean theorem. 2 squared plus 4 squared equals C squared. 2 squared is 4 plus 16. So C is the square root of 20. That simplifies. If you remember how we simplified our radicals, if you want to, I'm really not too picky about simplifying radicals for this chapter, but plus or minus 2 square root of 5 would be our square root of 20 simplified. Okay, and that's going to tell us where our foci are. Our foci are up here somewhere, 2 square root of 5, so that's just over 4. Just over 4, and since our foci are on the y-axis, those points are 0 plus or minus 2 square root of 5.